Well, hi, good morning. Thanks so much for joining me here in my shop for another day with this radio. Took me a little bit of effort to come in here today because I'm facing something here I really not sure at all how I'm going to fix it. And at the end of the last video on this radio, I broke one of the pins off here in this radio. Kind of see it floating there. We're going to take a close look with the other camera here and try to come up with some plan or some kind of approach here. So there it is, clearly broken. Well, it's not really broken off, it's actually broken out of. Was there no metal down inside the well, it's down there, but quite a way. So this actually broke off down inside there. I wonder if I pulled the tube out, is the rest of the socket going to come out on the tube pin and be completely out of there? Well, that's an interesting question. The answer is no. It does not come out. Wow, short of replacing this, and I do not want to do it. Boy, oh boy. What pin was that on this? It's pin 1, wasn't it? And pin 1 was one of the heater pins. So, there's some really crummy things I can do. I can actually attach a wire to the tube pin. That's lots of problems. The tube won't seat in the socket properly if you have a blob of solder on one of the pins. But that's one approach, which I don't like. I don't have any approaches here. I'm approachless on this. I was kind of thinking of pushing some wire or something through the socket. Hopefully connect everything up again. There's not a lot of room in these socket things, but I bet you I could pass a wire alongside the pin and have the wire come out the bottom. If I could do that, that would be pretty much a solution right there. I just need a nice piece of bare wire to try this with. There's usually a bunch on my bench here. Nothing long enough. See what happens if you try pushing a wire through one of these sockets. Okay, so this one here. Oh. Remnants of the socket, I think, are in the way. You can get all the way through. I think the wire may be too fat too. Yeah, it's actually too fat to get through there. Very thin piece of wire. Boy, oh boy. Okay. actually enough wire there to try it. Doesn't want to come through this way. Right through, right through. So the idea would be now I plug the tube in. I'm not going to do it because it's maybe kind of a one-time thing. Plug it in. Just have this soldered. You know what? This can be done. This can be done. That's what the insulation on this wire. There we go. Now I'm going to replace this anyway, so this kind of has to happen now, I think. This is a 25 volt, 250 volt. Oh yeah, this is the one this is 200 on the schematic, 250 here. 250, 25 volt, 250, that's a whopper. 25 volts, 250. 250, I got a 330. 50 volts at 220. How about that? Let's take a look at what we got here. 50 volts to 220. 330. This is a 220 here. 50 volts. Okay, we'll use that. Took my snow tires off yesterday and put the regular tires on my car, and my back is very sore today. I'm assuming from that. Okay, so we're going to cut away this positive here. Put the positive. Wow, could that go right through? Be the connector? Stick with the plan. Hey, where's that nice piece of wire? Where'd my nice piece of wire go? Oh. Well, I have to get another one. Son of a gun. Oh. Okay, I never actually cut the wire from the bail. Here it is. Push this through this way. Make the solder connections. Pull it back up a ways and leave it sticking out the top. I think that's the way to do it. Okay, so we're coming in from the top. It's got a bend. Go right through. I want to go on to this connector right here. Okay, take the capacitor positive lead. Should have put some insulation on this. I can hear Mr. Tactalibus telling me that right now. Mr. Tactalibus was one of my very first viewers years ago. and I was very unsure of what I was doing. This whole YouTube thing is a complete accident, believe it or not. And no intentions of ever making YouTube, public videos. I thought I can make videos for my customers, and then they can see, whoops, on the positive. Ooh, boy, did I almost make a bad mistake there. I'd make videos for customers to see me, live videos. I didn't know anything about YouTube and, putting your own videos up. It all happened kind of by accident. Accidental YouTube channel. But when you look back at life, if it's like my life, I think I'm like everybody. A lot of things happen in life that you really didn't plan on. Like good things. Good things happen. Serendipity happens. And how much of our lives are actually guided by that serendipity? I think a lot. We sort of spend our lives kind of making do with what has happened to us, with the part that we can't control. Well, that's going to work. If I solder that, which I'm going to, because we're really going to try this out. A bit of a mess here on my bench. I need to take some time to straighten it up. But I'm too excited right now to try this. So inside the socket, I imagine the tube pin will slide in, probably contact the wire, maybe not, be in its thing, and the wire will be in there with it. So maybe the wire will make contact to the thing, and the pin will contact the thing too. Got that? Right, can't do anything without the soldering iron here. Actually, after yesterday, I decided to set this radio aside. But then today I decided otherwise. I'm going to continue with it. Okay, very good on that. Let's get rid of this other part here. Can it reach all that way? No, it cannot. So I'm going to put another piece of wire in. Let's use this one. Get rid of this piece here. So you've had very unusual, excellent weather here. Yesterday it was very much like summer outside. Not supposed to be. Oh, look at that. Okay, that's better. Just like summer. Yeah, just like summer, and I'm just now taking the snow tires off my truck. And there's still a good chance of a snowstorm coming. But at this time of year, if it does snow, the snow generally melts off, within a day or something like that. It's not the same as in the winter when the snow falls and it stays. Okay. So give me a touch of a COVID update here. So Canada has, some of the political leaders in Canada have suddenly woken up and decided that a disaster is happening. They've gone in a week from saying, no, we don't think a shutdown's needed to, holy smokes, it's a disaster. It's really kind of corny to listen to these guys. I have one politician here actually suggesting he didn't realize how bad it was. How can that possibly be? The infection level in Canada is just about the same as the United States. The same ratios in the population. We're no better off here. And so as much as Canadians, me included, we like to poke at the United States, of course. Of course we do. No room for poking right now. The predictions here in Canada are dire. That's all I can say. They're just dire. It's stunning. Now, not all the politicians have suddenly started singing a different tune. The other politicians have been trying their best to bring about, whatever has to happen. So right now, the state of affairs in my province is we are in a supposed stay-at-home order and lockdown. But because the government has used these definitions and terms repeatedly in different situations, no one really knows what they mean anymore, and they don't mean much in themselves, do they? Stay at home is rather clear. Lockdown is not clear because many businesses are allowed to continue to operate or operate under different terms. So it's confusing to people. They don't know what to do. These people yesterday was the first day of the lockdown. Day before, stores jammed with people trying to get in there before the lockdown happens or the stay-at-home order happens. We went shopping yesterday. Nobody in the stores. So what are people thinking in their heads? That, the lockdown is to help us be safe while we go out shopping. So it makes no sense to rush out ahead of time and get into a crowded store with people who probably generally have a lackadaisical attitude about the whole thing. What is wrong with people? Boy, that's a big question, isn't it? We could talk about that one all day. Me too. What's wrong with me? Lots of stuff. Kind of a. Just has a funny feeling because the tube socket is free. It has play in it, so it makes the wire feel like it's not soldered. Okay, up above on the top side. So I'm going to push this over. I'm going to take the tube. We're going to jam it in there. Okay, that was no big deal. I'm going to leave the tail hanging out here for now. The tail of wire. I'm going to cut it a little bit since it looks like a bit of an antenna, but oh my gosh, what's going on with the camera? It's a bit of an antenna here, but it is on the tube socket circuit. Okay, you know what? I think that would work. It's a stupid way to do it, or is it? Not really. Because, the alternative is to try to replace that socket. And my guess is, by the time that's done, there'll be 5 more similar problems in the radio. You end up going downhill. Just worried these 2 terminals are getting into contact here. Very, very close. Oh, that's right. It's just on a piece of wire now. I can bend it. There's a little nubbin there. Maybe I can cut away the nubbin. Okay, nubbin is gone. Somewhere. Went somewhere. Don't know where. Okay, with its full load of crapola capacitors. Well, actually, it's not the full load, is it? I've replaced a couple. We are going to try to run this radio. Should I leave it up on its side? Why not? Because you spark some fire. We want to get a good view of it when it happens. generally sparks and fire come out the bottom. Okay. Now to start this up, yeah, so this trouble is in the heater string, and I'm so panicky about the heaters in these tubes. And they're all in. Oh, I never dealt with the switch. I never dealt with the switch. Ah. Okay, I've got to finish the switch deal here. Right. So my thinking here was to simply, yeah, short the switch out and I've removed the other wires. Short the switch out. I still can't believe the switch doesn't work. So one wire's on this resistor. Pretty stiff. End up replacing that resistor, which is probably the easiest thing to do. It runs from here to here. That's a was it 2700? It's I can see the colors here. Brown, black, red. Brown, black, red. 1,000. It's a 1,000 ohm resistor. Where's there a 1,000 ohm resistor in here? Thousand ohms. Connected to the heater, going to the black wire. 1,000 ohms. No, that's not connected to the heater. We're supposed to be over here somewhere. 1,200 ohms. So 1,200 ohms. Connected to the switch on one end, and the other end going to the big resistor. There it is. So this is a 1,200. Why did I read 1,000 on it? Did I read it the wrong way? Well, 1,200 or 1,000, either way. So I need to put if I follow this, 1,200 from here to here. Out from here. Oh, I've got my phone in my pocket again. So when I have my phone in my pocket, my phone, of course, will transmit from time to time, and it puts noise on my videos. So I apologize if that's been happening here and there. We don't care about this terminal at all. Here's the resistor. Brown, black, red. Let's check it for fun here. That's right, boys and girls. Checking resistors is fun. As they would say in Buffalo. Fun? Wow. And we think it's 1,000. $1,300. This is 1,300. Radio's calling for 1,200, and I picked up 1,000 here. Is this really 1,000? Sure is. Let's see if I can find a 1,200. Well, okay, so is it a 1,000 ohm resistor? Is it a 1,300 ohm that should be in there? Or is it 1,200 like on here? Like on the schematic? Good question, because I don't have an exact 1,200 here that I can easily pop in. Except for this, well, even that's not exact. That's 1,250, really close. But look at the size of it, and I waste a big resistor in here. So I started thinking, well, what is this resistor actually doing in the circuit? So we're looking at the power supply coming through the diode right here. Next thing is a 50 ohm resistor That's this part up here. And then that's followed by a 2500 ohm resistor. And then we're into the heater string. And that's the rest of this. The resistor in question, it comes off between these two. It comes off right here. And where's it go? It heads to the switch. There's another filter capacitor hidden in here. It's hard to spot. And then this is the feed to the plates. Feed to the plates. There's a dot right there, and it's also feeding up in here. So we have all the tube currents going through the 1200. Those currents, the tube currents and the heater currents, are adding in this 50 ohm resistor. And that's part of the voltage drop from the supply. The supply was a selenium rectifier originally. Now it's a silicon in there. Be a little extra voltage available here already. Maybe 5% or maybe 10% extra voltage here, which means 5 or 10% extra current in the heaters. And if I manipulate this, the value of this resistor here, if I change it, say from the planned 1200 on here to 1000, we would get, well, what would we get? So this is a really good question. First thing, a lower resistance, more current, but maybe not, because of why? Because actually a lower resistance would put a higher voltage onto the plates and draw more current through the tubes. That current's not going through here, just through the 50. 50 is small. You can't get big voltage drop changes on a 50 from a little bit of current variation. So maybe this isn't so critical. The tube currents are controlled by a number of factors, not just the B plus that reaches them. So the difference between putting 1000 in here and 1200, well, that's roughly that's like a 20% increase over it. 20% increase in voltage, current. Down. Well, I'm going to stick a 1000 ohm resistor here. Why am I doing that? Because the one I took out is very clearly 1000. And this schematic is, it's pasted right into the cabinet. What were they doing? Maybe they had an excess of 1000 ohm resistors. You know, these 1 watt 1000 ohm resistors. And the word was use them up. So what could happen? So if I'm putting in a too small, too high voltage, more current, bigger voltage here, dropping on the 50, less heater current. Smaller resistor here, less heater current. I like that. Let's try that. We'll put in 1000. Okay, big debate. 200 ohms. In it goes. Okay, got the resistor installed. Got the other wire moved up to here. So now the excuse me, the switches. The AC/DC battery switch is eliminated. New diode in there. One capacitor changed out. Positive, negative done right. This is bolted down now. Okay, I think we're ready to give it a try. see if anything at all can work in this radio. The big issue here is burning these tubes out. So to flip it back up here, I'm going to monitor. I want to monitor the voltage coming out of the end of this 2500, which is right here, relative to way over here, relative to a neutral wire. Keep an eye on that. And 7.5 volts is the magic number. Okay, so we'll put this here. I think I'm going to use my digital meter for this. And the other to this terminal here will do. And I can go right here. Right there. That's good. Okay, so this meter is going to tell us the voltage on the heater string, which apparently should be 7.5 volts. 7.5 volts. 7.5 volts might be negative or positive. Doesn't really matter. What about monitoring the B plus itself? It's not that critical actually. B plus could be up or down 20, 30 volts. Won't really matter that much. Certainly not at this point. It's all about the heater string. Now, I think that's it. Okay. Quiet moment there. The way we're going to want to do this, we're going to want to raise the voltage slowly using this guy while watching this one and seeing what happens. This should get all the way up to 117, and then this should be hitting 7.5 at that point. And I think we can be pretty reassured that everything's good if that happens. Okay, so the radio should be, we should start with it switched off. Okay, and we're going to go through the dim lights for no good reason. This won't come to life until the voltage is around 50 or so. Okay, so switch is off here. Measuring current on here. And we shouldn't see any. We shouldn't see any problem with my arrangement here. No current flowing. Okay, so we'll go back to output volts. This will read volts now. 120 is over here. Watch this meter. As soon as we see something on this meter, oh, now we switch on. Switch on. Whoa! Hot diggity dog! What happened there? What's that? 152 volts. What? So the decimal point is like this meter just getting worse all the time. So we have minus 1.2 volts, probably dissipating from one of those big capacitors. How do we get that much on there already? Did I click the set right off again? I think I did. Because the voltage here, the supply voltage, is nil. Where did that come from? Well, nil may not be nil. Here we go. If you add an S to the end of nil, you have my middle name. Okay. Well, still not sure why we're getting a volt there on the meter, but let's raise it up here a bit. Ooh, look at it go. Oh my gosh, I've hardly moved this. This is reading the output of this directly? No, this is on DC. So it's reading the output on the other side of the diode. 7 is the killer. 7. Well, something's not adding up here already. I go a little bit higher. Oh my gosh, I'm barely turning this big knob. Phew. Okay, turn it back down. What's going wrong here? Something's going incredibly wrong. Reading the wrong voltage. I'm on the long end of the big resistor. be wrong? How can that be wrong? I'm on the far end of the big resistor. And I'm reading back to a minus point. Is this... Oh, this minus point may not... Oh, well, there's the other one. That's definitely a minus point there. Let's read the voltage at this point. Okay, take it off here. Now we don't know at this point what is happening with the... Exactly the same reading. No current flowing in the resistor. You get the same reading on all the terminals. If there's an open circuit past the end of this resistor and there's no current flowing, because I've already blown open the heaters in the tubes, they're already gone, it's already over, game over. If the heater string is open circuit, then the voltage would just show up here. There's no drop on the resistor, so you'd see the whole supply voltage coming through. Boy, this is so unnerving. I just... Ay. I don't know. I'm kind of stuck here a little bit. Well, the question would be, did I open circuit the heaters already in one of these tubes? Many years ago, working on a radio not unlike this, I blew all 4 or 5 tube filaments, gone together all at once. And just totally unnerved here. Let's just go over a few things. The output from the supply is 0. Still a tiny bit of voltage hanging around. It's hard to know if there's no current flowing in this resistor. You'd have exactly the same voltage drop here as here. Now, I mean, the radio's not operating right now, but let's just take a look and see. Of course, the thing is, the tubes are open. You know what? The tubes are open circuit until the heaters heat up. So we got just under minus a volt. Same thing there, pretty well. So you won't have any conduction in the plate circuit until the tubes are heated up. The main load on this supply has got to be the tube heaters. What are they drawing? The tube heaters draw, it's 150 milliamps. These tubes, they're all the same. So one, so what do we got? There we are, 1R5. Let's look at that, 1R5. Filament current, 0.05 amps, 50 milliamps. So it's a 50 milliamp deal. 50 milliamps. If you run 50 milliamps through a 2500 resistor, that's 50 Oh my God. So there's no current flowing in the plate circuit. There's no voltage drop here. The plate voltage will be the same as the voltage at this point. And the voltage at this point is dropped over this resistor due to the current flowing in the heaters. So if you have, like, out of this rectifier is going to be like 150 volts here, and you want to get it down to 7. Wow, that's a long ways. And you got 50 milliamps. You got 50 milliamps, and I've got a calculator. It's getting more and more dangerous in here all the time. 50 milliamps, right? So if you have a pencil, you have 50 milliamps. 0.05 amps flowing through 1200 ohms. So oh, I got it all turned around. I got this all turned around in my head. How did I do that? Somewhere I got everything spun around. So the current in the 1000 is the plate current. It's the current in the 2500 that I want to measure. Ah. Okay. Sooner or later I'll get this right. So now 2500, if you have 50, so we're looking for 50 volts on the 2500, 50 milliamps flowing through a 2500 ohm resistor. So yeah, I did this wrong. So it's almost double this. So we go 50 milliamps. What am I doing? Help me out. Somebody, quickly. Just shoot me. This morning I should be shot. Put me out of my misery. 0.05 times all of 2500. So that's 5 times 25. It's 125 volts. Now this is another stupid result. I'm only supplying it with 120 volts. Nevertheless, almost the entire supply voltage should be showing up across this resistor, of course, because we're trying to leave 7 volts for the tubes and waste the rest of it on this heater here. Okay, so current flowing in that resistor indicates current flowing in the heaters. Okay. And we're looking for a pretty high voltage, so I'll put this on 20 anyway. Should get there pretty quick. Gain check radio on. Everything's set to go still. Here we go. There's nothing showing up there at all. And there's a voltage here. What's happening? That's a good question. I'm definitely connected right across the big resistor. I'm reading DC volts. 20. Not reading anything. The diode there This is the input side. 100 potentially 120 volts sitting right there. Not now though. On this side of the diode behind the resistor reaches the top of the big resistor. Well, we're going to revert right back to is there any AC getting here? Put this on the AC side of things here. Basically here and here. So I'm just reading straight AC coming out just on the end of the power wire. That's what we're reading. It says 44 there. Turn it up a bit. Why didn't it jump way up? Am I going up so smally? Try it again. Okay, so this guy is telling me there's 10 volts supplied, and this guy's telling me there's only one over here. How can that be? Okay, break it with this. Okay, put this back in this way. 10 volts heading here, only 1 volt showing up. How can that be? This is just ridiculous. So I'm right on the end of the wire. Let me turn this off. I should be able to see the full 120 volts here. Should be something there now. There's nothing there. Oh, whoa. Let's try that again. Here we go. How can that be 1.9 volts? It's 30 on this supply meter. What's happening? Volts. The radio's off. What the heck is going on? Did I grab a power cord that's got no that's not continuous? How can this be? Am I using the wrong? I got a bad clip lead. Oh my God, don't tell me it's a bad clip lead again. No, don't tell me this. Where's my clip lead checker? Clip lead checker is missing. Another part of my house. Okay, we'll use the ohm meter. Make sure this is off. Checking the white clip lead. White clip lead, good. Checking the yellow clip lead. Wow, you son of a gun. It's like I can't keep ahead of these clip leads. I mark it defective and hang it over yonder with the others that I marked defective. I have soldered all these, but I guess, I don't know, my soldering is giving out? I don't get it. Oh my gosh, see how serious the situation could have gotten? Yeah, I could have just been cranking the voltage up higher and higher and higher. Okay, do we need to go all the way? No, we don't. We just need to start back where we were before. So we're at 20. I like reading the current through the big resistor. Or read the voltage drop across it, rather. I like that idea. Go on there. And the other fantastic clip lead. Down here. Okay, now the radio's turned off, so we'll start with that. Start with it off. Nothing should happen on that meter. Would appear to be nothing, and we got 20 volts coming over. Okay, now we're going to do this. And I'm going to remind myself 50 milliamps through a 2500 ohm resistor gives you a 125 volt drop. That's more than the supply. It's a big supply. So let's just say we should pretty much see the same voltage here as we see here. No. There we go. Let's see what happens. Stop talking and see what happens. Nothing happening. Oh my gosh. Well, that's, according to my theory here, means there's no current flowing in the heaters. I did turn it on, didn't I? Yes, I did. I do have this set. Everything's going here. So this is telling me no current flow in the big resistor, which is telling me no current flow in the heaters, which is really not what I want to hear. I don't want to hear that. Am I making a mistake here? No. It's B plus out of here, heaters out of there. I don't see any voltage. Let's turn this up again a little bit. Okay. I did turn it on. Yes, I did. Well, how else are we going to know if there's any current flowing in these tubes? Let me wiggle the one that I worked on. Maybe it's intermittent or something. Okay, watch the meter. No, not very likely. It's really very likely it made contact just fine. Wiggle the other tubes around. Pull one out. No. Never pull one of these tubes out when there's any chance of it set operating. Oh my, this is just like a dead ender at every turn. Voltage coming out of the supply. Okay, so we'll read that by going negative here. Oh, so there's B plus building up. Crank this down a bit. Goes away, crank it up, comes back. Okay, so we are succeeding in feeding some rectified voltage into the top of this resistor and detecting it down here, 20.8. Now, if there's 20.8 volts down here, no current flowing in the resistor at all. Well, I think there's two switches on the back of this switch. It's possible that one of the two switches is not switching. Is there really two switches back there? No, there isn't. No, there isn't. Look on the schematic. Look upon the schematic. No, that's right. It's a yeah, this shows two switches. A two-pole single throw. Two-pole single throw. And yeah, you know what? There is connections on there's 4 terminals on the back of the switch there. It's possible the switch isn't working. That would result in voltage across the switch. That would result in the same voltage I gotta stop and think. I'm overloaded here. It's just taken me into a zone I wasn't prepared to go in, and I just got all kinds of knots in my head now. I have to de-knot myself. Coffee might help with that. So I've been thinking that there must be obviously a less intrusive or dangerous way of finding out if there's conduction through the 4 tube heaters. And sure, why don't I take my own meter? I'll tell you why, it's not even here in the shop anymore. Oh, I have to go get my own meter. Okay, so what I've got going here is the clip lead to the bottom of the resistor, which is the start of the heater string, one end of the heater string. And I have the other clip, the green clip, going to the B- wire, and that should be right through the heater string. So put this down to something a little more realistic. Let's check it first. There we are. Here we go. Oh. Well, I guess that qualifies as an open circuit. Radio switched on. I have to test these tubes. Now all these tubes were pre-tested. This is a really bad sign. I mean, the last time I blew tubes up in a radio, it was just like this. There was absolutely no indication anything had happened until I tested them and found them all defective. Okay, so that's what I'm going to do. I'm going to test these guys. Oh, I just feel so bad. Okay, let's give it a test. But if you look, you can see that book down there. I think I read a little bit of that book about how to determine the polarity of a circuit or some wires, and it involves some pretty crazy ways of doing it without a voltmeter, like sticking wires in salty water and stuff. I thought it was pretty crazy. Since I read that part, while touring around the internet, I found a advertisement or something like that for a device made way back when they'd be telling people to do those things to determine polarity, like is written in that book. An actual device you could buy to determine the polarity of wires, and it was a little tube, looked like a tube, and in it was some liquid. And what you do is you hook this tube up to your wires, and one end of the tube will turn red. And what's in the tube? Phenolphthalein, the same stuff that they were talking about in that book. So here's a device somebody manufactured and sold as a tool or an instrument for somebody to use to determine polarity. But you think at that point, you buy a voltmeter, for crying out loud, or make your own or do something rather than use phenolphthalein in a tube. How strange is that? Okay, now the truth be told. So this is a 3S4. This is the only one I've got. I tested this good previously. I tested it in a different tester, not that that should matter. So I've got it set up here. I just want to be sure now. We're testing it with a filament voltage of 1.5 volts. It's a 3 volt tube, 1.5 volts because the heater is center tapped. And so you can feed in the 1.5 from both ends and get in effect 3. Signal 1, 22H on the bias setting. 63547. 63547. P600. P600. 20C. Okay, everything's set to go. This is it. My little tube. What will you do? Just for all the tube testing aficionados, we will check the line here, which is running high. Okay, any shorts? On this tube tester, shorts show up as a meter reading. Short on 1. There's a note here, note F. F means you will encounter a short on pin 1. So that's normal. That's quite common on a lot of tubes. We are ready now for the test. here we go. It's P1 and P2. P1 and P2. 3S4. There's two plates inside this tube. Look at that. Okay, so thank God. This one's good. Let's do the P2 thing and see what happens. Yeah, good. Show. Okay, so my nice 3S4 is a nice 3S4. Whew! Now I've got duplicates of all the rest of the tubes, but not that one. So I'm going to test the rest here. Okay, ready to go on the 1T4. Now, the P1, whoops, the P1, P2 thing on the last tube is because the plate is attached to two different pins. So this is testing either pin connection to the one plate that's in the tube. That's what was going on there. 1T4, 1.5 volts, signal level 2, 0 bias, 7340K, 7340K, 5600, 40 C. We're ready to go. Here we go. These tubes also, they heat up like that because there's no cathode in them. They run right off the heater, which is one of the secrets of their low power operation. If you're going to have a cathode with a heater inside, then you got to get this heater pretty darn hot to get the cathode hot enough. So that's a bit of an energy loss, if you like. But if you can just operate with the heater and use that as your cathode, like a rectifier tube does, then you don't have to put as much power into this. It's all part of the battery side of things. Okay, so no need to delay. That's what I was explaining. There's the short on pin 1. There's a note F here. Everything is good. We are ready now. 1T4. What do? Up you go. Now, it's supposed to go up to 580. It's double. It's more than double the expected amount. So she's a beaut. Oh, there's two things here. Put it back in. Wasn't there two things? K1, K2. Yeah. So just to make sure, there's two. The cathode is connected to two pins on this tube, and they both work. Good. Okay. This guy passed the test. Okay, on to the next one. Okay, 1R5. Let's double check. Always double check. 1.5. 1R5. 2, 0. 7345K. 7345K. 5600. 600. 48. On C, we're good to go. Now, a couple of the tubes in this radio have resistors across the heater. So if the tube heater is open, the resistor will still conduct current. But two tubes don't have that arrangement. This is one of them, and we already tested the other one. So if this one is open circuited on the heater, it'll explain what has happened. But I'll bet you it's not. Here we go. The short on 1 as expected. 1R5 should come up 1000. K1, K2, whole tube test. Look at that. K1, K2. K2 must be another one of the both leads working. This tube's good. Oh my gosh, we've only got one. I think I only have one more left. Okay, here we go. So now this is the only tube that is left to explain what is happening. But my guess is this tube will test fine. So it's a 1U5, 2, 0, 73400, 73400, 5600, 41 sensitivity, C for the plate. We're ready to go. There's a note F. We should find a short on pin 1. There it is. Or setting 1, not pin 1, setting 1. And here we go. 1U5 is supposed to come up. No, not very high. That's a 2-part tube. I'm not sure it makes any difference though from the heater point of view. Hey, it might. Okay, because the numbers are very different. So we'll dual test this. So 410, it's only got to come up to about there. What? Oh. What's happening there? My switch is breaking. Okay, so it's come up to, you know what, it's 500. So it's over the 410. And what's this next thing? It's testing a diode in there. Let's pull it out. We'll set it up. 70030. 70030. I won't double check these numbers because you're watching. And if I make a mistake, I'm sure you'll let me know. 0600. 48. 8. Well, what are you supposed to get here? It just has a dash there. Has a dash for the reject point. Diode's okay. That's why. It's a diode. Okay. I'm okay. Everything's okay. 105. 1U5 rather. Okay. I'm gonna hit together, I think. Here we go. Fire 1. So this is the other part of the tube. If you're flipping this, get a big D there for diode. So we're going to flip this. There it goes. Well above the diode's okay. So what I've done is I've proven that all these tubes are working. So I've proven I haven't blown the radio up, which is good. 2, the problem is not an open circuit in the heaters themselves. The problem is, see, we don't know what the problem is. We don't know what has happened here. So, you know, there's a good chance the work I did earlier, I moved it up somehow. As careful as I was, I've moved it up somehow. So I think that's where I'm going to leave it today. Again, just kind of in the fog. But I think I'm going to stop at this point. So thanks a lot for watching, and I'm going to push forward again with this radio tomorrow and try to sort out what has happened to it. See ya.